Good afternoon, student. Today we see the next point of the vector analysis. Till we have learned about the scalar quantities and its properties. Again, we learn about the vector quantities and its properties and examples also. Today we start the next part of the vector analysis chapter, gradient of scalar field. Before starting the point gradient of scalar field, we must have to know the two things: the first del operator and second what is the scalar field. So out of that, first I'll tell you about the del operator. What is the del operator? The del operator, and this del operator is denoted by this. Okay, and how, what is the del operator? The del operator, del bar is equal to I cap dou by dou x plus z cap dou by dou y plus k cap dou by dou z. It is the del operator. It is the del operator. Now we see about the scalar field. What is the scalar field? The scalar field is when a scalar quantity can be assigned to every point in the space. Okay, a scalar quantity can be assigned to every point in a space. It is called as the scalar field. For example, the temperature distribution in the medium. Temperatureचं distribution medium मध्ये असेल तर what is this? It is a scalar quantity assigned to every point in the medium. Similarly, electric potential, it is also the example of the scalar field. Magnetic potential is also the example of the scalar field, and very well known example, gravitational potential, which is distributed everywhere in the space, or that gravitational potential, it is a scalar quantity which is assigned to every point in the space. Okay, so what we see now, the del operator, and another one is the scalar field. So now we learn about the definition of gradient of phi. A gradient of phi, we can denote this gradient of phi like del bar phi. Okay, we denote the gradient of phi like this or like this, grad phi or del bar phi. This is the notation of what? It is a gradient of phi, or we can write the gradient of phi like this, del bar phi. Suppose if phi is a scalar quantity, is a scalar field. What is the phi? Phi is the scalar field. Then the quantity I cap dou phi by dou x plus z cap dou phi by dou y plus k cap dou phi by dou z is called the gradient of phi. It is denoted as I say before, grad phi, or you can write del bar phi. It is the gradient of phi. Now the function phi denoted by grad phi. Let phi is equal to the phi of x, y, z, or it is the phi of r bar, right? And what is r bar? It is r bar is I cap x plus j cap y plus k cap z. So how we can write this? Dr bar is equal to I cap dx plus j cap dy plus k cap dz. And differential of phi is, and the differential of phi is d phi is equal to dou phi by dou x dx plus dou phi by dou y dy plus dou phi by dou z dz. हेच आपण कसं लिहू शकतो? हाऊ वी कॅन राईट इट? इज इक्वल टू I cap dou phi by I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z. Okay, and into I cap dx plus j cap dy plus k cap dz, which is equal to, this is what? This is the del operator, del bar into what is this? This is phi. As we see before, the what it is? It is d phi into what is this? This is, we see before, this is dr bar, means del bar phi into dr bar. Okay, in a first bracket, what is this quantity? This quantity is nothing but the del bar phi into dr bar, which is, in another we can write the gradient of phi into dr bar. Okay, this is about the scalar, this is about the gradient of scalar field, and this is the definition of the gradient of scalar function 5.